Hi, this is Josh Bollinger, Communications Coordinator at the Harry R. Hughes Center for Agro-Ecology, a nonprofit organization affiliated with the University of Maryland College of Agriculture and Natural Resources, and we're producing this limited series podcast. This is the second of 3 episodes on the Delmarva Peninsula and the increasingly visible issues that its people and land are experiencing related to saltwater intrusion. In this episode, we meet Dr. Pinki Mondal with the University of Delaware and Dr. Keryn Gedan with the George Washington University. They're both collaborating with the University of Maryland to research saltwater intrusion and determine the extent of its impact on the Delmarva Peninsula, which consists of the coastal areas of Delaware, Maryland, and Virginia. If you want to learn more about what saltwater intrusion is and what it does to the agricultural crops here on the shore, check out the first episode with the University of Maryland's Agro-Ecology Lab Director, Dr. Kate Tully, and her field technician, Brian Moyer. But for an expanded look at what the research is saying about saltwater intrusion on Delmarva, stay tuned. All right, well, thanks for joining me today. Pinki, why don't you go ahead and introduce yourself?
Thanks for having me here, Josh. My name is Dr. Pinki Mondal. I am an assistant professor in the Department of Geography and Spatial Sciences at the University of Delaware. I do hold a joint appointment in the Department of Plant and Soil Sciences at UD, also a resident faculty member at the UD Data Science Institute.
How about you, Keryn?
Hi, great to be here. I'm Keryn Gedan. I'm an associate professor at the Department of Biological Sciences at George Washington University, and I'm a plant community ecologist, work in the coastal zone.
Well, thank you. Thanks for both being here today. So what we're talking about, and this is a limited series, we're in the second of 3 episodes. The first episode we discussed with Dr. Kate Tully about what her particular research on the Delmarva Peninsula is regarding saltwater intrusion. But what I'm really interested here today is to discuss how both of your focuses in this work tie in there and how they complement each other here on this recording right now. How does each of your work complement each other? I don't know who wants to jump in first. You're both welcome to freely exchange ideas here. But yeah, how did this, I guess we could start with Keryn. I know that Kate has told me a couple of times that you were sort of part of the reason why she got into this. Why don't we start there and then we'll go from there? Does that sound good?
Yeah, sure. Yeah, it was happenstance that Kate and I met at University of Maryland, and I was already working on saltwater intrusion and sea level rise issues in coastal wetlands and coastal forests. And I started talking to Kate about agricultural lands and she said, well, what's happening on the coastal agricultural lands? I said, well, we have no idea. Let's go see. So that kind of launched, 7 or 8 years of research now, and a collaboration that's grown and grown and grown. And one of the things that Kate and I realized early on was that we lacked several types of expertise that would be really helpful in understanding the system. Kate's background is in soil science and biogeochemistry, agroecology, and then my background is in plant community ecology, kind of what plant species are occurring there and their performance. And so, yeah, we started bringing in new expertise, and Pinki was one of the people that we grabbed and hoped she might work with us.
What were you doing at the time, Pinki?
I was traveling around the world thinking about how our environment is changing, and I do that utilizing satellite images. Once I joined University of Delaware in 2018, I believe Kate contacted me in 2019, and that's when I started learning about this important issue of saltwater intrusion. My background is in satellite remote sensing, so I utilize satellite images to look at any kind of changes that's happening anywhere in the world. And when I learned about saltwater intrusion, I just became interested in how we can utilize this vast amount of data that we have from the 1970s and see how our environment is changing, especially because of saltwater intrusion. I was just so surprised to know that this kind of impact that saltwater intrusion can have on soil surface, it can leave a visible mark that can be picked up by satellite images.
And Keryn, so Pinki just sort of discussed what her focus is. What's your focus, and why don't you guys discuss how it complements the work?
Sure. So I think when we first found these fields that were being impacted by saltwater intrusion, I was very excited because there's a lot of change happening in the coastal zone due to sea level rise, and one of the processes that's happening is that tidal wetlands are moving upslope. And that's a process that's really important for the survival of that important ecosystem. So there needs to be places upslope where tidal marshes can migrate into. One of those places is these farmlands that are affected by saltwater intrusion. So we started finding these areas that were, not performing very well in terms of crop yields, and we saw the salt marsh grasses creeping in. And so I was really interested in the changes that occur in the plant communities after farming stops on these farm fields that are affected by sea level rise. So I started studying what plants come into those lands and how the community starts to assemble into a plant community from this very kind of heavy-handed human dominated community, of crops and agricultural weeds, and then shifting into species that are naturally occurring, but disturbance kind of respond positively to disturbance, like plowing and open space and fertilizers, pesticides, and then to more naturally recruiting species that are common in wetlands. So I was studying that transition in the plant communities and trying to understand if those areas are going to look like our natural tidal wetland plant communities in the future, or are they going to be different because of invasive species or because of these legacies of nutrients and soil amendments. So that's sort of where my work falls in, and this kind of grew into some ideas of maybe we can even plant something on these lands to either keep them in productivity longer for the farmers by planting species that are more salt tolerant that will be able to survive in this salty environment, or we can think about transitional or restoration species that might help that tidal marsh plant community kind of establish there and get going. So we started in my lab kind of exploring different species and their survival in these lands. And as a group, we brought in an agronomist as well who has worked with some salt-tolerant crops there. We planted some perennial grasses. So we've done a lot of kind of field experiments to test out these species on these salt-affected lands. So these field experiments are very naturally small scale. We can only do this like at these much smaller than a field scale. So we usually use a portion of the field. We do what's called strip trials, like just kind of maybe 60-meter plots. And immediately just start to wonder, like, well, what's happening on the field next door? What's happening in the whole county? What's happening at the scale of the region? And that's the kind of area where Pinki's collaboration became so important, because we wanted to see, like, how important is this? How much area is being affected, and where is it? And then can we use landscape predictors to think about why it's happening, where it's happening, and get this kind of larger scale understanding.
Yeah, let's get into that recent paper that you put out. Why don't you just overview? Yeah, I think you know what I'm talking about. Why don't you overview what it is, what it said?
Sure. So we knew from all these excellent field experiments that my collaborators have been doing for a while, and we knew that we need to scale up. And that's where satellite imaging comes in, because it can not only go back in time, it can also scale up and it takes it from the field level study to a state level study to even national or global, depending on the problem. So what we learned that these coastal mid-Atlantic farms were turning too salty to make profit. And we wanted to know where we are seeing these visible salt patches, how can we map those so that we know how much of productive farmlands are very near of these visible salt patches, because traditionally this was a problem that was invisible, so it was sort of challenging to convince people that this is happening. But we knew that crops were dying, people were making less profit, so it gave us a great opportunity to capture these visible salt patches that pretty much acted as a clue to capture this silent disease. And we are seeing these visible patches more and more, not just growing in size, but increasing in numbers and affecting more farms. And that's where we started with this study. But what we also did is not only we captured these numbers and these sizes of these visible salt patches, we calculated how much farmland converted into marshland, which is another proxy to see how these salt affected lands are changing in terms of species, something that Keryn was explaining to us. And then we tried to look at the cost of it. So not just the environmental change, but the economic impact. Delaware and other coastal counties that we studied in this paper, which is the coastal Delmarva, coastal counties of Delaware, Maryland, and Virginia, they are primarily corn soybean economy. And corn does not really like salt. So as we are seeing more and more farmlands are being salt impacted, we wanted to calculate how much farmland is at risk and what's that looks like in terms of dollar amount. And we found that if we are thinking just 100% corn, that could be over 100 million a year in profit loss. Now, soybean does a little better in terms of salt tolerance and thriving in a salty environment. But even then, for a 100% soybean scenario, it could be 40 million a year. I think attaching these dollar amounts, it just brought too much attention. So now people are talking about it because, we obviously would like to keep the land in productivity or at least do something about it. So I think this is a good way to draw the attention that has been going on for a while. It was just not known the extent of it.
Yeah, sometimes you need to put hard numbers to an issue for someone who's not involved in it every day for it to really catch their attention. Our policymakers also deal with a number of other different issues. So anytime we can provide like hard numbers like you did, that paper was wonderful for doing that. Let's go ahead, Keryn.
Yeah, well, I just want to say, even for the farmers that we were working with, because we do a lot of this work on private land, and the property owners have been great partners, allowing us to come take samples and pictures and measurements. But even for them, they didn't always see this as their most pressing problem. So like you were mentioned with the policymakers, it's also the property owners. Sometimes they say, well, yeah, that field's not performing so well, but my real problem is the deer that hit every field, or, my real problem is the prices for seed or whatever. So they have a lot of pressing problems. So I think this also, like Pinky's study, really helped to highlight that this is affecting, it's not just like, that one field. It's affecting everybody in these coastal counties to just a little bit. It might not be their most pressing problem, but once you look like across this big scale, it is quite a big problem.
I thought the one thing that was pretty poignant was that Pinky, how you said these patches and the evidence for it is becoming more and more visible, because Kate Tully used to describe it as the invisible flood, and that's actually the title of the first episode. Spoiler alert! But I may rethink what to name this one, because you're right. It is becoming more and more visible. I mean, you can see. I've been out to cornfields that aren't growing properly because they're intruded with salt. So, yeah, I and especially from like a mapping sense, I can see how you can really get an idea how visible it could be from space, right? So I wanted to talk a little bit about the benefits you may see from this multi-institution partnership. I don't see that very often in science. with in agriculture, I suppose, more where there's multiple institutions over a region beyond like the Chesapeake Bay program stuff working on a particular agriculturally related issue. So what are your thoughts on that, you know, on this sort of sharing ideas between institutions?
I think it's a real strength of our project. I mean, we're as a group, we work really well together. I think we have a lot of fun on our meetings and our field trips. But I don't know. I think we have very diverse expertise in our group. And yeah, it always, someone always brings up a new interesting idea. I've had all these, we have a stakeholder meeting every year to kind of share our findings with the farmers and also some, you know, different land managers and agencies. And yeah, I always find the drive down to the stakeholder meeting to be the most fun because we usually carpool from different regions. I mean, I'm coming from DC and Pinky's coming from Delaware, but we take a few people in each car, and those discussions are always the best. On the way there, we're thinking about, you know, the results we want to share and where the research is going and kind of exciting new ideas. And then on the way home, it's even more fun because we have to digest all the comments from our stakeholders. And so, yeah, it's great.
Well, I want to know a little bit more about your personal reasons why you're interested in this topic. I know you've both been involved in this for a number of years now, and you're continuing to do research on it. I just sort of want to poke at why. Do you feel invested in this research at this point?
Yeah, I can start. So, you know, as an environmental geographer, I was trained as an interdisciplinary scientist, and I have worked with people from diverse backgrounds, academic or, you know, otherwise. And I must say that this group of people, this is by far my most favorite one, because we do share a passion to bring some changes on the ground. I have been working on understanding how our environment is changing for a while now in different contexts, in different countries. Before coming to Delaware, I have been working in different parts of India, in Vietnam, in different parts of Western African countries. My focus had been until then to understand how people have been changing landscapes throughout the years, but also how our landscapes are changing in response to different changes in temperature and rainfall, and how that affects agricultural productivity. Once I came to Delaware, I realized how low-lying this region could be, because on my walk to campus, often days it will be flooded. It will be gone in days, but like in hours, but that was the first time it was very visible to me that this is a problem, and I'm not even on an agricultural field here. And I started thinking about, this could be a real problem for the farmers, because not all crops really like to stand in water for a longer time, right? So that's when I started thinking about it. And when I was introduced to this project, it became very clear to me that this is a problem, and this is a problem that's not going away anytime soon unless we take action now. And satellite imaging and satellite remote sensing analysis can give us the right platform to share these results with our end users. So it could be decision makers, landscape managers, farmers, or policymakers, because as a geographer, I could also make beautiful maps, although that's not my only job responsibility, but it's easy to convey a message with a map, with something that you can see and interact with. We created an app using our data that we generated for this paper, where people can interact with that app. They can zoom in on their background or their backyard, and then they see how things have been changing over the years. And I think that gives a great way for people to realize how important this is, for our agriculture, but also for our economy, our livelihoods. And that's why I feel very invested, because using my science and my training, Hopefully, we can bring in some changes, some policy changes, some management strategies that will help us lead towards a more resilient future. And I also feel very invested because we have been working with great group of early career scholars, our students, and I feel like just training them, it just gives me so much pleasure, and it's very rewarding because it's going to be their world after us, and they need to know about all these pressing issues now and have all the skill sets so that they can make a change.
Absolutely. Keryn, what about you?
I would say that I'm a Maryland native, and I grew up in the western part of the state that's very kind of mountain facing. And I, as an adult, became kind of enamored with the Chesapeake Bay, and my background's in tidal wetlands, and I see the effects happening in the uplands very much tied to the future of tidal wetlands. And the future of tidal wetlands in the Chesapeake Bay is very much in jeopardy because of sea level rise. A lot of modeling studies predict high amounts of habitat loss, like up to 95% habitat loss in our tidal wetlands within 100 years. So that's that's really a scary thought to me, and really makes me motivated to try to protect what we can and understand the changes that are happening. I've always been really interested in global change and climate change. I think that climate change is one of the greatest challenges of our time. And, this is how we respond to climate change, by understanding the problem and developing solutions and adaptive management that can, respond when there's change. So, studying the changes happening in Delmarva and trying to develop policy tools and management planning tools that can help farmers decide what to do with these lands, as well as feeding into processes like they're developing easements for marginal croplands affected by sea level rise. And so there's all kinds of things that we can actually do. And if you drive around on the Delmarva Peninsula, you'll see roads that are flooded. You'll see houses that are abandoned because they've been, basically taken over by the marsh. And yeah, it just seems like there are people there being affected by climate change, and I want to, understand the issue and see where it is we can provide solutions.
I always wondered, after you sort of alluded to this, we study an issue and then create policy around it. We're in that stage, I think, right now where there's been several papers around this that have come out. Um, and what kind of are you all involved in policy discussions? Well, I mean, what kind of things do you, what kind of responses, I suppose, are you seeing on the ground in response to your own research?
Well, I guess I link in with like a whole other kind of policy realm, but I am not myself in that field to develop policy tools.
Sure.
Like the things that we can do is there's a lot of, for example, incentive programs for farmers. Like there's an equip program that helps them decide on what to do with marginal fields, and management practices that can be useful there to wildlife, and for keeping the environment healthy, like soil health and things like that. And there's also like other subsidy programs, incentive programs like the CREP program, or the Conservation Reserve Enhancement Program. That's CREP. Or the Wetlands Reserve Program. There's a number of these types of programs that the lands being affected by sea level rise on Delmarva are probably eligible for, but right now are not being, those tools are not being used in this situation. So we're kind of trying to come up with, okay, what would maybe some equip management recommendations be for salt affected lands? Like we could have, for example, um, salt tolerant species included in the species that are provided by the EQIP program or recommended by the EQIP program to plant on these marginal areas. One of the things we've tried to do actually is create a salt tolerant pollinator mix, because one of the EQIP programs is to plant um, plant species that support pollinators, and that helps us have a natural, healthy community of pollinators, which then comes back around and benefits people because they pollinate all our fruits and some of our crops. Um, so yeah, we've been working on it also happens to usually pollinator mixes produce a lot of flowers and they look really beautiful too. So there's that benefit as well. So we're developing this salt tolerant mix for pollinators that is building on work done by folks in Virginia on the NRCS. So we kind of took something that they developed and then added a few species and tried planting it in a few farms in Maryland, and we're seeing how it performs. So far, we've got some promising results there too.
I think that's why interdisciplinary studies like that, like ours, can bring in the attention that this pressing issue demands, because we all have our own academic groups that we can take the findings to, but also by bringing together a diverse group of people along with the users or the farmers that we do at our stakeholder meetings. We have people from different state agencies, Maryland State of Planning, I have been talking to people in geological surveys in Delaware, in New Jersey, and I think that is important. Any solution, it starts from a conversation, and we are hearing of this problem not just in Delmarva, but elsewhere, like in New Jersey, in the Carolinas, or even outside the US. So this is an important issue, and it's important to have this solution, have this conversation to get started, and providing a platform for that is very important. So I think that's where this kind of interdisciplinary work and these kind of meetings are important, to bring together people from diverse backgrounds, whether they're in a state agency, a federal agency, policymakers, farmers. We all need to talk together. We all need to be together and talk about these issues and what kind of solutions. Because what I feel like, the policymakers can come up with policies, but what is very important to know that what the farmers are thinking. It's their land. Some of the times these lands have been in their families for generations. What's their preference? And then as scientists, we can see if what they think, if their preferences are are a valid solution. Sometimes they are, sometimes they're not. And then we have to continue with that conversation saying, hey, if this is not the best case scenario, what else would you go for? So I think that conversation is very important. And, having a platform for that, it matters.
Yeah, well, I definitely agree with that. Well, I wonder if we could discuss what you're working on now. Do you? I guess I imagine there's like a paper ends. There's still some unanswered questions, and there's an idea for a new study, or like how does that typically run? But anyway, what are you working on right now regarding this field?
Yeah, I can share what we are doing. So in the paper that we are talking about, we looked at how the landscape has changed between 2011 and 2017. The reason for that was the data that we used that were available for those years. And when we started looking at this data, we did not have any recent data available to us. The moment we published that study, I wanted to do more. I wanted to know what's going on right now. And one trade-off that we have with aerial data is that it's only available every other year, sometimes every 3 years. Satellite data, which is, it has fewer details. In our language, we call it's a coarser data, but it comes in more frequently. So some of the data that I utilized, they are available across the world every 5 days or every 12 days or 16 days. What we learned from our study, the past study, that things can change quickly. So we can have a patch that appeared on a farmland this year. Next year, it might be gone. That does not mean that it's completely gone. The salinity is gone. It's just that we don't see it on the land, on the soil surface. So I wanted to utilize this huge volume of data that's available to us, and it's taxpayers' money, so it's already paid for, so it's available to us for free. How we can utilize these satellite images to know what's going on a more regular basis, so maybe on a seasonal basis, or maybe at least on an annual basis. And that's what we have been focusing our efforts on. Right now, I can tell we have developed a data set for 2019 to all the way to 2023. And the method is such that we can continue having this data for each year going forward. And we are already seeing a threefold increase in salt patches. And looking at that data, it's kind of concerning, because you can see how it's fluctuating, where it's fluctuating, and also it gives you this opportunity to study why this is happening. If we are looking at an increase in number or a growth in size, why that form? Why not the other? So having this data would enable us to delve deeper. So that's what I'm excited about right now, as one of my PhD students is looking into that. And more papers will come out soon, hopefully later this year, and some more next year. I'm also very excited about combining our individual work with Keryn, with Kate, and other PIs on this project, because I just love this interdisciplinary work.
That's I am really kind of surprised to hear that, but it's good to hear. One of the biggest complaints I hear in research is the delay in years you're studying, right? Because you only have data sets from 5 years ago on a particular issue, and it may not be completely up to date. So it's very interesting to hear that. It sounds pretty up to date what you're looking at. Keryn, what about you? What are you working on right now?
Well, so one of our findings from these farm fields is that after farming stops, they start to become very shrubby. So the shrubs respond really quickly, and it starts to become very woody. And that it's not really like a bad thing. They're native species, and they definitely have wildlife value, but people don't always like it. There's a it can be hard to move across those lands, hard to use them for different things, and so usually a lot of farmers choose to mow them, and that seems to keep woody species out. So that's something that I want to look into next, is like, what is the effect of mowing on those plant communities? Like, does that facilitate grass dominance, and especially the species that are present in natural tidal wetlands coming in faster because they don't have to compete with these shrubs that shade the ground. So that's something I want to look into, and I also want to look into prescribed burns as a management practice. So that's another tool that's kind of at landowners' disposal. It can be, obviously has to be used carefully with training and in the right conditions, but it is also a useful tool for keeping woody things, suppressing woody plant species. And in particular, I'm also interested in the dynamics of a very prevalent invasive species in this landscape called Phragmites australis, the common reed. And so I'm always interested in how these management practices also shape the environment to either, favor or keep out this invasive species. And hopefully we can use management to keep it out of lands that are undergoing change.
Well, there's only a handful of you researching this here in the region, but it seems like you're making a pretty significant dent in a lot of the questions that have come up around it in the past couple of years. So I just want to say thank you for continuing to research this topic. I think it's critically important for our region. And then I just wanted to follow up real quick with the paper and app we were talking about. Pinki, where can people find that information? I can post it in the description too, but
Sure. So I am a big supporter for open data and open science. So I whatever I publish or my group publishes, we share the data freely, so anyone can download any kind of data that we have worked with. So the data that we used for this paper are readily available for anyone to download. Just know that it's huge in size, so if you do not intend to actually use the data, the other way to look at the data is to look at the app. And both the data and the app link are available on our research website, which is www.easel-lab-mondal.com. If there are different tabs, so you can interact with the different tabs. You can go to the publications tab, where you would be able to look at the link of the data sets that we have distributed for anyone to use. You can also go to the research page to find the link to the app, and then it's an app for a computer but also a mobile app, so you can always go play it with on your phone and just learn more about how the landscape is changing.
Cool. And then Keryn, can people go somewhere to find more about your work?
Sure. They can go to my lab webpage, which is www.gedanlab.com.
Great. Well, thanks again for joining me today. Any last words?
It was great to be here. Thanks for all your questions and for organizing this, Josh.
Sure.
Thank you, Josh. It's always a pleasure to talk to you, and especially with Keryn, because we definitely do share the passion. And I'm just happy that we have a platform now through your podcast, Limited Series Podcast, to reach out to even more people.
Let's hope. Well, thank you again. Have a good one, everyone.
Bye.
Thank you.